Mercury chloride. A mercuric chloride is the chemical compound of mercury and chlorine with the formula mercury 2 chloride. This white crystalline solid is a laboratory reagent and a molecular compound, once used as a treatment for syphilis. It is no longer used for medicinal purposes because of mercury toxicity and the availability of superior treatments, production and basic properties. Mercuric chloride exists not as a salt composed of discrete ions, but rather is composed of linear triatomic molecules, hence its tendency to sublime. In the crystal, each mercury atom is bonded to two close chloride ligands with HgCl distance of 2.38 A. 6 more chlorides are more distant at 3.38 A. Mercuric chloride is obtained by the action of chlorine on mercury. A mercury chloride by the addition of hydrochloric acid to a hot, concentrated solution of mercury compounds such as the nitrate, mercury 1 nitrate plus 2 hydrogen chloride, mercury 2 chloride plus H2O plus NO2. Heating a mixture of solid mercury sulfate and sodium chloride also affords volatile mercury 2 chloride, which sublimes and condenses in the form of small rhombic crystals. Its solubility increases from 6% at 20 degrees Celsius to 36% in 100 degrees Celsius. In the presence of chloride ions, it dissolves to give the tetrahedral coordination complex 2-. Applications. The main application of mercuric chloride is as a catalyst for the conversion of acetylene to vinyl chloride, the precursor to polyvinyl chloride. C2H2 plus hydrogen chloride CH2 equals CHCl. For this application, the mercuric chloride is supported on carbon in concentrations of about 5 weight%. This technology has been eclipsed by the thermal cracking of 1,2-dichloroethane. Other significant applications of mercuric chloride include its use as a depolarizer in batteries and as a reagent in organic synthesis and analytical chemistry. It is being used in plant tissue culture or for surface sterilization of explants such as leaf or stem nodes. As a chemical reagent, mercuric chloride is occasionally used to form an amalgam with metals, such as aluminium. Upon treatment with an aqueous solution of mercuric chloride, aluminium strips quickly become covered by a thin layer of the amalgam. Normally, aluminium is protected by a thin layer of oxide, thus making it inert. Once amalgamated, aluminium can undergo a variety of reactions. For example, it will dissolve in water. Halocarbons react with amalgamated aluminium in the Barbier reaction. These alkylaluminium compounds are nucleophilic and can be used in a similar fashion to the Grignard reagent. Amalgamated aluminium is also used as a reducing agent in organic synthesis. Zinc is also commonly amalgamated using mercuric chloride. Mercuric chloride is used to remove dithion groups attached to a carbonyl in an upper-lung reaction. This reaction exploits the high affinity of Hg2 plus 4 anionic sulfur ligands. Mercuric chloride may be used as a stabilizing agent for chemicals and analytical samples. Care must be taken to ensure the detected mercuric chloride does not eclipse the signals of other components in the sample, such as is possible in gas chromatography. Historic use in photography. Mercury chloride was used as a photographic intensifier to produce positive pictures in the collodion process of the 1800s. When applied to a negative, the mercury chloride whitens and thickens the image, thereby increasing the opacity of the shadows and creating the illusion of a positive image. Historic use in preservation. For the preservation of anthropological and biological specimens during the late 19th and early 20th centuries, objects were dipped in or were painted with a mercuric solution. This was done to prevent the specimen's destruction by moths, mites and mold. Objects in drawers were protected by scattering crystalline mercuric chloride over them. It finds minor use in tanning, and wood was preserved by ionizing. Mercuric chloride was one of the three chemicals used for railroad tie wood treatment between 1830 and 1856 in Europe and the United States. Limited railroad ties were treated in the United States until there were concerns over lumber shortages in the 1890s. The process was generally abandoned because mercuric chloride was water-soluble and not effective for the long term, as well as poisonous. Furthermore, alternative treatment processes, such as copper sulfate, zinc chloride, and ultimately creosote, were found to be less toxic. Limited ionizing was used for some railroad ties in the 1890s and early 1900s. Historic use in medicine. Mercuric chloride was used to disinfect wounds by Arab physicians in the Middle Ages. It continued to be used by Arab doctors into the 20th century, until modern medicine deemed it unsafe for use. Syphilis was frequently treated with mercuric chloride before the advent of antibiotics. It was inhaled, ingested, injected, and applied topically. Both mercuric chloride treatment for syphilis and poisoning during the course of treatment was so common that the latter's symptoms were often confused with those of syphilis. This use of salts of white mercury is referred to in the English language folk song The Unfortunate Rake. Historic use in crime. In Volume 5 of Alexandre Dumas' celebrated crimes, he recounts the history of Antoine François Desroses, who killed a noblewoman, Madame de la Motte, with corrosive sublimate. Toxicity. Mercuric chloride is highly toxic, both acutely and as a cumulative poison.